2 times 4 minus 6.
Okay, so we would plug in 4 for n. So that's 2 times 4 minus 6. And then what value did you get when you did that?
2.
Very good. That should be 8 minus 6, which is, in fact, 2. Are there any questions on number 1? So again, notice when I simplified this expression, work down the page, right? These are good habits to get in. You should be working down the page, not left to right. Notice that my problem didn't start with an equal sign, so I never put an equal sign, right? Set it up the way the problem looks. Pick a number 1 through 18. No, not 18. Come on, Cody.
You know I had a lot of these on that.
Pick a number 1 through 25. It's 21. Okay. What did you get on number 2?
I'm not sure if I'm right.
Okay, that's
But I put 2 times 5 minus 6 equals 4.
okay. Why did you put 2 times 5 minus 6?
Because I was moving really quickly and I did some weird math for what 2 and minus 6 would equal for f of 4.
Okay. Tay.
I put f parentheses 4 equals 2 parentheses 4 minus 6.
Okay, so if we're evaluating the function f of n at the x value 4, that means what? I want to input 4 for n. So go over here and put in 4. Yeah, just substitution. Substitute a 4n for n. Now if I simplify this, 2 times 4 is 8 minus 6, which gives me a value of 2. So what we would say here, my final answer would look like f of 4 equals 2.
Wow, Austin.
Because it started in function notation, so I want to end the problem in function notation. Right? Keep the same form. That's what it started with.
It'd be positive because I can demonstrate the problem.
So what do we do here? You substitute
-6.
-6 in for z. And so what does this look like now? It should be parenthesis -6 squared.
Y'all is wrong, bro.
And then what is -6 times -6?
That'd be 36. Positive.
It's going to be positive 36. A negative times a negative is a positive. If you're dependent on your calculator, if you put -6 squared in your calculator, it's only going to square 6. And it's going to put the negative back in front.
You gotta put it in parentheses.
So if I want the negative included, I need all of that in parentheses.
Yeah, that's what I.
Okay.
That's what I did. Yeah, that's what I got.
I knew that a negative and negative makes a positive, so why not listen to his calculator?
I don't know. That's a good question. Do you know how smart the calculator is?
Smarter than me.
Only as smart as the user. Okay, look at 4. 4 says to evaluate f. I didn't. I'm just telling you. The calculator knows nothing more than what you put in it.
He's not wrong.
It knows nothing more than what you put in it.
Oh my God, Coach, you just blamed it.
That wasn't supposed to be. That wasn't supposed to be.
Fine.
4. Evaluate f of -6 for f of z equals z squared. Pick a number 1 through 25. It's 15.
Well, you have it down, so I don't know how to do it.
But okay, it's gonna be f parentheses -6.
Okay, how do we read that?
Squared.
We don't read it as f parentheses -6.
Okay, f.
F of
Okay. F of -6.
There you go.
C -6 squared. Or -6 squared.
What?
No, I didn't got the.
What'd you say again?
F of -6 equals -6 squared. Now,
Now you saw it.
should that negative be in parentheses or no?
Yes.
yeah.
We plug -6 into z. What was supposed to get squared? All of z. So if I plugged it in for z, then I need negative 6 all to be squared.
That would equal f of negative 6 equals 36.
And so f of negative 6 is negative 6 squared is 36.
36.
Questions there? You see how it started in function notation? So my answer's in function notation. Okay, let's look at number 5. Evaluate 3x squared minus 1 for x equals negative 2. Pick a number 1 through 25. 8. You don't have it? Okay, well, look back at what we did before. What do you think we're supposed to do? Okay, well, it tells me what x is supposed to be right here. X is supposed to be negative 2. So now, instead of saying x, I'm going to say negative 2. I drew my arrow and y'all couldn't see it where I drew it. So in here for x, I'm going to plug in negative 2. That gives 3 times negative 2 squared. Minus 1. I just substitute in. If x is negative 2, put in negative 2. Now if I put all this in my calculator, it is going to be 11. Because, let's do it without a calculator though. Let's see if we remember. What am I supposed to do first here? PEMDAS.
Please excuse my giving aside.
So, do I have anything to simplify inside parentheses? No.
There's not any question in the parentheses.
There's nothing inside the parentheses that needs to be simplified. What are these parentheses telling me to do?
To multiply.
Multiply. So these parentheses mean multiply. They're not telling me simplify what's inside there because there's nothing in there to simplify. So parentheses, I'm good. Do you understand that?
So those parentheses is another type of multiplication.
Correct. If the parentheses looked like this, negative 2 times 3 plus 8, and then you had minus 11,
Then you simplify.
simplify everything in parentheses first. And you still follow the order of operations inside there. Even if there was a number out front that was multiplying. These parentheses tell me to multiply, but there's stuff inside to simplify. So I'm going to simplify everything inside first, then multiply.
In that case, when there's a variable, like, say if negative 2x times 3 plus 8, you distribute first, right?
No. I would need to write this as a single term first. So that would be negative 6x, then distribute.
Oh, okay, so you just distribute to that x, right? Or
You distribute the 2, that would be 2 times negative 6x, and 2 times 8.
oh, so you just leave the variable alone.
What do you mean leave it alone?
Like you wouldn't multiply.
Yeah, you can multiply by variables and numbers. You just can't add and subtract them if they don't look the same. But if they are multiplying or dividing, you can multiply or divide anything. So like we'll look at something later, okay? I don't want to get too far down a rabbit hole. Okay, look at, back at this problem. We had no parentheses. Do I have an exponent?
Yes.
Yes. Negative 2 squared. Some of y'all are going to be hurting when we get to the test. I'm just telling you. Negative 2 squared is 4 minus 1. Negative 2 times negative 2 is 4. Now, do I have any more exponents?
No.
Next, multiply and divide. 3 times 4 is 12 minus 1. That's how I do it without a calculator. And then if I look at 6, what's happening here? It's the same problem in a different form. Right, I'm going to substitute negative 2 in for x. 3 times negative 2 squared minus 1. Negative 2 squared is 4. 3 times 4 is 12, which gives 11.
So f of negative 2 equals 11.
So notice my answer started in function notation and it ends in function notation. Did I simplify anything over here with this function notation? F of negative 2 is never going to change. Don't think I got to get rid of that negative 2. I'm going to see people divide by negative 2 when we start doing these. Because f is being multiplied by negative 2, so I divide by negative 2. No, this whole thing is called function notation. You never do any math with function notation. It's just a fancy way to write the problem, essentially. Questions? Okay, so hopefully we've got our answer. I'm sure most of y'all put in your calculator. What did you get when you put in your calculator? 32. All right, let's do it without a calculator to see. See if that calculator can be trusted.
I got it, already got it without the calculator.
You did it without the calculator?
Yeah.
And you got 32? What'd you get?
I got negative 13.
I mean 12.
I got 22.
I got 24. I got 21.
Okay, well, I'm hearing all these answers. That means we probably need to practice simplifying using PEMDAS. You guys agree? Yeah. Do I have anything in parentheses that needs to be simplified? No, there's nothing in parentheses to simplify. So now I'm going to get rid of any exponents. Do I have any exponents?
No.
I actually do.
Oh, so we count that?
A square root is kind of like an exponent because you can write the square root of 64 as 64 to the 1/2 power. You guys remember writing powers as exponents? Square roots as exponents? Maybe. You should have done that in 8th grade. So the square root of 64 is 64 to the 1/2. So that is an exponent. So what is the square root of 64? 8. Do I have any more exponents? No, so I'm going to bring everything else down.
I'm gonna write this over here.
Now, do I have any multiplication or division?
You got both.
I have both. That is a division at the end, isn't it?
Yeah, it is.
Almost couldn't tell. So, do I have to do all multiplication and then do all division? Is that the rule? No, you can see when I write PEMDAS, look at the way I write it. I stack my M and D on top of each other. Why? Because we do all multiplication and division at the same time from left to right.
What was that variable up there? It was like 4 to the 1/2 power.
64 to the 1/2?
Yes, 64 to the 1/2.
Yep. Square root's the same thing as 1/2 power. Okay, so let's look for any multiplying and dividing as we come to it. So I'm starting over here.
2 times 3.
2 times 3 is the first one I see. 2 times 3 is 6. 2 times 4 is 8. 8 divided by 2 is 4. That's the only multiplying and dividing I had. So bring everything else down.
Is that not negative?
That's a negative 2. Right?
Uh-huh.
Oh, he's
Uh-huh.
gonna add it. If y'all don't quit.
That's a negative 8 there. That's one way. I wrote it a little differently, but you could have written negative 8 there, and that'd have been fine too. Now, is there any addition and subtraction?
Yes.
So do I do all addition and then all subtraction? No, you do them at the same time as you come to them from left to right. That's why I stack my A and my S. 24 minus 2 is 22. 22 plus 6 is 28. 28 and 8 is 36. 36 minus 8 is 28. 28 and 4 is
32.
32. Now, you don't have to go left to right like I did on the board. If I was trying to do this in my head, I would look at it and say 8 minus 8 is 0.
Yeah, that's what I
4 and 6 is 10. 10 and 24 is 34 minus 2. 32.
Yeah.
That's what I'd have done. Because when everything's adding and subtracting, you can do it in any order you want to. It doesn't have to be left to right. Just combine them. Okay? So on A, if I'm evaluating f of negative 2, I've got 3 functions to choose from here. How do I know which one they want me to use? I'm going to use the function named f because it has the letter f. That points me to which function to use. So here, I'm going to be using function f. And instead of saying f of x, I'm now evaluating it at a specific input, negative 2. So I am plugging in negative 2 for x. So this looks like negative 2 squared minus 4.
You're wrong. I got it wrong.
You didn't put the negative 2 in parentheses? So again,
And he had
Well, I have a good reason
says,
though.
okay?
But on the first like paper we done, it was in, like the 2 was outside of it, so it's not on there like that.
Okay.
So I thought it was.
And that's one of the hardest things to get used to. Here's my question. What's being squared? All of x. What did I put in for x? So it has to be included in the squaring. Okay? If you didn't put in there, this is different. If the function was negative x squared minus 4, this negative out front wouldn't be included. Because the negative was already here, but it tells me to only square x. So like, I'm going to make this j of x. Okay, we'll work this in a second. So if I have negative 2 squared minus 4, negative 2 times negative 2 is 4 minus 4. 4 minus 4 is 0. So f of negative 2 is 0. That's how we work down the page. Now if I did j, b is f of 1/2. So which function am I going to plug into? F. So if I'm finding f of 1/2, that's going to give me 1/2 squared minus 4.
Is it okay that I went ahead and simplified that 1/2?
That's 0.5?
Yeah.
That's okay.
yeah, that's what I did too.
I would say we've got to get more used to fractions because fractions aren't going anywhere. 1/2 times 1/2 should be 1/4 minus 4.
What? Just keep going.
1/2 times 1/2 is 1/4.
Oh, yeah.
If you have half of 1/2,
I don't know. I did it as an estimate.
0.25.
Yeah,
That's a quarter. This is a quarter. 1/4 is 1/4. Yours was 1/4. 1/4 minus 4 is, y'all got negative 3.75, which I'm going to write as negative, that's wrong, 15/4.
Wait, so what would my answer be?
Negative 3.75.
Okay.
Now again, I messed up. Why did I mess up right there?
Why is it negative?
Because 4 is the bigger number. You have a quarter and you owe $4, right? You have 0.25 and you subtracted 4. No?
I got it.
If it was 4 minus 0.25, it would be positive. Okay, for C, f of 3. This is going to be 3 squared minus 4, which would be 9 minus 4, which means f of 3 equals 5. You can. There's nothing wrong if you put that in parentheses.
See, that's bad because I got the other two right, and I did it the same way you just did it. I got A wrong.
What did you get? Oh, A?
Yeah,
That's okay.
like I done B and C like just like that. It's like, I don't
You just
know-
didn't put parentheses on A.
I don't know why.
Well, these, you didn't miss these because there was no negative number. This one was positive and this one was positive.
I guess, I don't know.
That's it. Did you get negative 8 on the first one? That's all it is the negative. Any questions on these three? I mean, do you think you can do this? You're given a function, you're given an input, you plug the input in. All right, we're not doing super challenging stuff yet. All right, we're building to it. Okay, look at D.
This one,
What does D, that's why I didn't want you to do it on your own. What does D tell me to do?
has 2 different variables minus G.
Okay, it's not necessarily 2 different variables.
Well, it's the same
This
variable.
represents 2 different functions.
Yeah.
2 completely different functions. I'm going to take the whole function f, and I'm going to subtract the whole function g. So this is called function subtraction. Whereas before we were just evaluating one function at a specific place. Here you're going to take whatever f of x is and subtract whatever g of x is. So what is f of x?
F of x
Look back at the top. What is f of x?
equals x squared minus 4.
So instead of saying f of x, I can say x squared minus 4 because they're equal to each other. F of x is x squared minus 4. And then I'm going to subtract all of g of x. What is g of x?
Negative x minus 5.
So here's the tricky part. There's a subtraction in my problem.
Yeah.
G has its own negative.
It's understood.
So make sure you have them both. Don't just write one of these negatives. They both need to be there. Because if this was adding, this would be plus all of that. Okay, now then, we're just going to simplify these 2 functions. Do I have anything in parentheses?
Yes.
Yeah. So I need to fix that first. Well, there's a negative out in front of it, so there's an understood negative 1 that you're going to have to distribute. Negative 1 times negative x is positive x. Negative 1 times negative 5 is positive 5. Then I bring down my other function. So now I have x squared minus 4 brought down plus x plus 5.
What I did here, kids, I like combine like terms.
Yeah, do I have any like terms?
Yes.
Where?
4 and 5 and x.
Okay,
X squared.
so negative 4 is like 5. They're both constants. They have no variable. So what is negative 4 plus 5? That's 1. So I've got a positive 1. Now I heard you say you combined x squared and x.
First I solved x squared. And it just, I put an x to that 'cause I didn't know.
So you can't simplify it. So if I have x squared, that means I have to take a number and multiply it by itself. But what number? I don't know. Any number. So I can't simplify this exponent for x squared. So this may be the first time y'all dealt with this. These are not like terms. To be a like term, it must be the same variable to the same power. These are the same variable, but they're not to the same power. One's to the second, one's to the first. So I can't combine them, so I just rewrite them. I'm going to have the x squared left over, And I'm going to have the positive x left over. I'm sorry, that went faster than I thought. That's exactly right. We're going to take all of f of x and then subtract 2 from it. So f of x was x squared minus 4. And then the problem said to subtract 2 from that. Do I have any like terms? Negative 4 minus 2. Yeah. X squared minus 6. All right, let's do F. I'm going to screw it up. And now I'm having to do it live, so I'll be slower. I haven't gotten to F all day. Okay, I've got h of x plus 1/2. So I go back at the top. What is h of x? X minus 2. Is it all over 3?
Yes.
Plus 1/2. So now, big picture, what am I being asked to do? Thank you. I'm adding 2 fractions. What must be true when you add 2 fractions? You have to have a common denominator. When you're adding or subtracting fractions, that's the only time you must have a common denominator. So, I don't know how you've drawn it in the past, but here's how I draw them. What is my current denominators? 3 and 2. What's going to be the common denominator? 6. So I go down beneath it and I rewrite them both with the denominator of 6. Then I ask a question. How did I get from 3 to 6? What happened for me to get from 3 to 6? I multiplied 3 by 2. Well, I'm not just allowed to multiply part of a fraction by 2. That changes the whole fraction. So if I multiply the top by 2 as well, then the fraction doesn't change. It's the same numbers, just in a different form. You guys understand what I mean when I say that? Yeah. Like if I had the fraction 2/3, if I multiply the bottom by 2, it becomes a 6. If I multiply the top by 2 as well, it's the same fraction. I just changed its form. So same thing here. If I decide to multiply the bottom by 2 to make it a 6, I have to multiply the numerator by 2. So it stays with the same form. So what gets multiplied by 2? All of that. So it's 2 times all of x minus 2. So I'll distribute it in a second. I'm just going to leave it like that for now so we can see what happened. Oh, no way that's when the bell rings. I thought the bell rang at 03. I got the wrong class. So the left fraction, 2 times x minus 2, let's distribute that. 2 times x is 2x. 2 times negative 2 is negative 4. And then I have what's in the other fraction? Plus 3. And now all of this is over 6. The whole point of getting a common denominator was so I could write it as a single fraction. So that's what I'm going to do. Write that as a single fraction. Now, are there any like terms in the numerator?
Yes, negative 4 and positive 3.
Negative 4 and positive 3. So let's combine those. Different sign, subtract. Keep the sign of the larger number. And so I am perfectly okay with this being the final answer. 2x minus 1 all over 6. Questions here? So look at A. What does A tell me? If we had to say that in words, what's happening?
Draw some ordered pairs and see which one.
No, just A. Like, look at A. If I said f of 1 equals negative 4, what does that mean in words? And don't say f of 1 equals negative 4.
The out.
1 is a function of negative 4.
So 1 was an input to a function. Right? That's why it's in parentheses. I put in a 1 and I got out -4. So that means the ordered pair that's happening here is an input of 1 and an output of -4. So that's my ordered pair. Parentheses? Is that what you're asking?
No, what is the two lines?
My parentheses?
Oh,
The comma?
yeah. Oh, yeah. Oh, yeah, I didn't know.
Sorry.
Hey.
It's a little better? Not really. Okay. 1, -4. Now for B, what would I write the ordered pair for B? Not out loud, not out loud. Pick a number 1 through 25. 15. 15.
That's
That's whatchamacallit.
I don't
15.
know- I don't know who 15 could be. I don't
No,
know.
I'm just going to throw this phone down and stomp on
Hey!
it. Oh,
Is that
obviously they're not here. No.
Oh, you're.
Hold on, let me delete where I'm recording myself. Delete the evidence. Okay, what do you get for B? Just the ordered pair.
Oh, -3, -2.
So I put in a -3 as my input, and I got out -2 as my output. So that's the ordered pair. -3, -2. Easy enough?
Yeah.
Function C, we look at that, and it's broken, right? No, it's not broken. What's my input? 0. What's my output? 0. So the ordered pair is 0, 0.
Origin.
Can I please,
Ooh, that is called the origin. Yeah, go ahead.
on D,
Yeah.
can I please do it as 0.5?
Um,
Can I run it as well, I mean like negative.
it's not technically wrong.
Now, how would you graph it?
Yeah. I would say, however it starts is the way it needs to end. That's my general rule. So like for D, it started as a fraction, -1/2. So I would want my answer to be a fraction. I don't want you to just convert it because you're not comfortable with one or the other. We've got to get where we're good with both, because on a multiple choice test, you don't know which one you're going to see. Okay, so sometimes sometimes you'll have decimals, sometimes you'll have fractions. I'm okay knowing to do it as a decimal, but I want you to be comfortable with both. So let's just leave it the way it started.
The -1, does that make that makes the whole fraction?
It does.
Right?
It does.
Okay.
So that's a good question.
Because like on that, I knew that it was gonna be a negative fraction, but like, why did they put it on the top numerator?
Preference. All of these are the same. -1/2, or 1/2, or -1/2. Right? Those all mean the same thing. The only way you can't say it is -1/2. That's wrong. Because what's a negative over a negative? Positive. So you can't put the negative over the negative.
So like, if we got that for an answer, it could be like, positive.
+1/2. Yep. Okay, so let's graph these points. Graph these ordered pairs. So when I look at my graph paper here, what do I notice? I don't have an x-axis or a y-axis. So let's draw them in.
Huh?
Okay? Because I'm trying to get it where y'all can see the ordered pairs, and just leave me alone, okay? Sometimes this thing doesn't work the way I want it to. That's good enough.
My bad, Pam. You did good.
Yeah.
Married.
Let's don't try that one again. Let's stick with Mr. Coots. Okay. So when I look at A is the ordered pair 1, -4. Pick a number 1 through 25. 12.
Dang it.
Oh my gosh. Congrats.
Come graph A. Pick a number 1 through 25. It's 24. 24. Will you graph B for me? Here, blue. Pick a number 1 through 25. It's 5. 5. Pick a number 1 through 25. 23. You've got C. Pick a number. I'm so sorry. Here, use one of those other green ones over there. They're better. Pick a number 1 through 25. 25. Do we have a 25 in here? We got D. Okay, so let's look at all these and see. For A, the ordered pair was 1, -4. So the 1 tells me to go which direction? Right, because it's positive. So right 1. The -4 is down 4. So that is the ordered pair 1, -4. That's good. Questions on A? B is -3, -2. The negative tells me to go left. So I'm going left 3. -2 means down 2. There's B. Very good. C is 0, 0. That means from the origin, I go nowhere left or right, nowhere up or down. So there is C. It's not much of a dot. It's kind of all over the place, but I'll take it. Okay, and then D, my x value is -1/2. So how do I go -1/2? Well, if this line is -1, -1/2, it's halfway between there. So I'm right here. And then the y value is 2. That's exactly where that should go. -1/2. Any questions on any of those? There's 1, -4. I'm going to put it on. If you're following along, I'm putting the dots on now so you can see where these should go. If you're having to watch this video later. Okay, so we've got a couple of new vocabulary words here. Look at 5. It says f of x is the same as
X of F.
blank. And then when I read underneath it, it says given the domain of -1, 0, and 1 for the function f of x equals 3 minus 2x. It tells me to state the values in the range for f of x. Okay, so what words in this statement are maybe new or a little confusing? Range.
Values.
Oh, values isn't. Range. Domain. Have you guys heard those before?
Yeah, but I don't know what they mean.
Okay.
These kind of new.
So here, let's do a quick little mini lesson before we answer this. Oh, this is the end of the lesson. Okay, so we have, so far we've been talking about inputs and outputs. Right, the input is what you put in, like that was me pressing the button on the vending machine. And we got an output. What was another way we could talk about input and output?
X and Y.
Inputs are just my X's. Outputs are my Y's. That was the next way we talked about input and output. Then we talked about another way to talk about input and output. Independent and dependent. The input is my independent variable. It's the thing I have a choice over. The output is my dependent variable. Okay, we're fixing to add something new to this. The list of all possible inputs is called my domain. Domain. It's just another word to talk about the x's, the independent variable, the inputs, the domain. And then if I want to talk about a list of everything that comes out, that's an output, we call that the range. Okay, so this is not like the range, and you may be used to mean, median, mode, range. This is a different kind of range, right? It's not the same vocabulary word. This range, again, is just a list of all possible outputs. Okay, so now then that we've talked about those, let's look back at the question, see if it makes more sense to me. Given a domain of -1, 0, and 1. So what's that really saying? The x's. Say I input -1, 0, and 1. Then state the values in the range for f of x. So what would happen if I plugged in -1 to this function, right? Because -1 is an input. And then what would happen if I plugged in 0, because 0 is an input. And what would happen if I plugged in 1, because 1 is an input. So they've given me my 3 inputs. So they put them in a fancy little brace. That brace really doesn't mean much of anything. It's just the way we talk about domain and range. It's a little more formal, it's a little fancier, but it's no different than what we did here. So what would f of -1 be? What does that even look like? I'm going to go to my function, and where there used to be an x, I'm now plugging in -1. So this would be 3 minus 2 times -1. Can y'all got? Oh, what happened? Why did it lag? Work! Okay, there it is. 3 minus 2 times -1. How could I simplify this? Well, I would need to do, we talked about PEMDAS. I need to do which one first, subtracting or multiplying? All right, obviously we need to write it down. PEMDAS, are there any parentheses? No. Are there any exponents? No. Is there multiplication or division? So we do it next. So I'm going to multiply -2 times -1, which is +2. Bring down the 3. 3 plus 2 is 5. So when I plugged in -1, the output was 5. Now let's do the same for 0. What if my input is 0? Well, that's going to look like 3 minus 2 times x, which is this time 0. -2 times 0 is 0, and 3 minus 0 is 3. So when I plugged in 0, my output was 3. And now let's plug in 1. Oh gosh, that does not do what it's supposed to do. There it goes. So if I plug in 1, that's going to be 3 minus 2 times x. This time x is 1. Do my multiplication. -2 times 1 is -2. 3 minus 2 is 1. So I input 1, and my output was 1. So now here's the answer to the question. The question is, what's the range? So again, whenever we talk about range, we have to do a little bit fancier. So if I wanted the range, I need to put a brace. And then we're going to put the range in order from the smallest to the largest value. So what was the smallest output I got? The smallest output was 1. What was the next smallest output? 3. And then what was the next smallest output? Were there any more outputs? No, those are the only 3 outputs. So that would be my range. 1, 3, and 5.
Bryce looks so cute.
You did a good job on it?
Yeah.
I had to work. I've been practicing for about 3 years, and I finally got mine to look acceptable. Okay? I know. It's real sad.
You are working on like hard drama.
Then we talked about, look at that first fill in the blank. I told you f of x is just another way to say what? It is. F of x is the dependent. It's the output. It's the dependent variable. It's our y. F of x just means y. So anytime we talk about the output, it's what do we get in the end. Like right here, this says f of -1 was 5. That means my y value is 5. This means my y value was 3. Right? It's just a fancier way to say it. Anytime you see f of x equals a number, they're telling you that the y value is that number. And then let's look at 6. 6 says find an equation of a linear function. Given h of 1 is 6, h of 4 is -3. Note, same as write the equation of a line given 2 points. So now this is a big step up, okay? This is a big step at once. Do you guys remember linear functions before? Maybe in 8th grade?
Yeah, a little
Where you had to graph a line? Okay. So what we're really doing, and we've kind of done this before. Do you remember in our last worksheet, we looked at all these different possible inputs?